Friends, let's solve multiple choice questions. Question number 1. How many molecules are there in 1 mole of water? We know that in 1 mole of water, number of molecules are 6.02 into 10 raised to power 23 molecules are present in 1 mole of water. So the answer is B part. Friends, let's solve question number 2. A flask contains 500 centimeter cube of sulfur dioxide at standard temperature pressure. The flask contains how many grams of sulfur dioxide? Let's solve this question. Let's calculate the molar mass of sulfur. The molar mass of sulfur dioxide, molar mass of sulfur dioxide is 64 gram per mole. How did you get the 64? Answer: the mass of sulfur is 32. The mass of one oxygen is 16. There are 2 oxygen atoms, so 16 multiplied by 2. When you will add these numbers together, the answer will be 64 gram per mole. Now, we know that 22.414 decimeter cube of sulfur dioxide at standard temperature pressure contains how many grams of sulfur dioxide? 64 grams of sulfur dioxide. We have calculated the molar mass. And if we convert the decimeter cube into centimeter cube, then your answer will be 22414 centimeter cube contains how many grams of sulfur dioxide? The answer will be the same, that is 64 gram of sulfur dioxide. 22.414 decimeter cube of sulfur dioxide contains 64 gram of sulfur dioxide. We have converted the decimeter cube into centimeter cube, so 22414 centimeter cube of sulfur dioxide will contains the same mass of sulfur dioxide, and 500 centimeter cube of sulfur dioxide contains how many grams of sulfur dioxide? The answer will be 64 divided by 22414 multiplied by 500. So your answer will be 1.427 grams, and D part will be correct answer. So how you have converted decimeter cube into centimeter cube? We know that 22.414, we know that 1 decimeter cube is equal to 1000 centimeter cube, and 22.414 decimeter cube is equal to 1000 divided by 1 multiplied by 22.414, and you will get the answer in centimeter cube, and the answer will be 22414 centimeter cube. So students, in this way we will convert decimeter cube into centimeter cube. So the answer is D part. Yes students, so the next question is, a necklace has 6 gram of diamond in it. Diamond means diamond is made up of carbon. A necklace has 6 gram of diamond in it. What are the number of atoms in it? 6 gram of diamond contains how many atoms? So diamond is carbon, so we know that 12 gram of carbon, or we can say that 12 gram of diamond contains how many atoms? 6.02 into 10 raised to power 23. Why? Because it is 1 mole. It is 1 mole of carbon. 12 gram means 1 mole carbon, and 1 mole of carbon, that is 12 gram of carbon, contains how many atoms of carbon? 6.02 into 10 raised to power 23 atoms of carbon are there. And if the mass of carbon, or if the mass of diamond is 6 gram, so 6 gram of carbon will contain how many atoms? The answer will be 6.02 into 10 raised to power 23 divided by 12 multiplied by 6, and your answer will be 3.01 into 10 raised to power 23 atoms will be there. In 6 grams of carbon, this much atoms of carbon will be present. So the correct answer is D part. Yes friends, so D part is the correct answer. Question number 4. What is the mass of aluminium in 204 gram of aluminium oxide? Yes friends, so first of all let's calculate the molar mass of aluminium oxide. The molar mass of aluminium oxide is, there are 2 aluminium atoms present, so 2 multiplied by 27 plus 3 oxygen atoms are present, so 3 multiplied by 16. 27 is the mass of aluminium and 16 is the mass of oxygen, so 27 multiplied by 2, that is equal to 54, plus 16 multiplied by 3, that is equal to 48, and the answer is 102 gram per mole. So students, molar mass of aluminium oxide is 102 gram per mole. So 102 gram of aluminium oxide contains how much gram of aluminium? We know that the mass of aluminium present in aluminium oxide is 54 gram. So 102 gram of aluminium oxide contains aluminium, that is equal to 54 gram. And what is the question? The question is 204 gram of aluminium oxide contains how many grams of aluminium? The answer will be 54 divided by 102 multiply by 204, and the answer will be 108. The answer will be 108 grams. Question number 5. The reactant which is consumed earlier and gives least quantity of product is the limiting reactant. Which one of the following compound contains the highest percentage by mass of nitrogen? In which compound the percentage by mass of nitrogen is greater? So students, let's calculate. In A part, molar mass of ammonia is 17 gram per mole. Mass of nitrogen is 14, mass of 3 hydrogen atom is 3, 14 plus 3 is equal to 17. So what is the percentage by mass of nitrogen in ammonia? Percentage by mass of nitrogen is, mass of nitrogen is 14 divided by total mass, that is 17, multiplied by 100. So the answer will be 82.3%. So B part. The next compound is N2H4. Molar mass of N2H4 is 32 gram per mole. 14 multiplied by 2 plus 4 multiplied by 1, so you will get 32. So what is the percentage of nitrogen in N2H4? Percentage of nitrogen is 14 multiplied by 2, that is equal to 28. What is the total mass of this compound? That is equal to 32 multiplied by 100. So what is the percentage by mass? That is equal to 87.5%. So in this compound the percentage is greater as compared to ammonia. Let's solve the C part. C part. What is the molar mass of NO? Molar mass of nitric oxide is 14 plus 16, and that is equal to 30 gram per mole. And what is the percentage of nitrogen in NO? Mass of nitrogen is 14 divided by, what is the total mass of this compound? 30 multiplied by 100. So the answer will be 46.6%. And D part, the last compound is NH2OH. Molar mass of NH2OH is 33 gram per mole, and the percentage of nitrogen in this compound is, only one nitrogen atom is present, so 14 gram. Total mass is 33 gram, multiply by 100. So the answer will be 42.42%. So the correct answer is B part, that is the highest percentage of nitrogen is present in N2H4, and that is 87.5%. So the correct answer is B part. Question number 7. Vitamin A has a molecular formula C20H30O. The number of vitamin A molecules in 500 milligram of its capsule will be. We have to calculate the molecules. Mass is given to you, but the mass is given in milligrams. You have to convert this mass into grams. Then you will calculate the molar mass from this formula, and then you will use the formula of molecules to calculate the number of molecules of vitamin A present. So let's solve this question, students. So let's calculate the molar mass of vitamin A. Molar mass of vitamin A is 286 gram per mole. So you will calculate how many carbon atoms are present in vitamin A. Let's see how many carbon atoms are present in this molecule. 20 carbon atoms are present, so 20 multiplied by 12 plus how many hydrogen atoms are present? 30 hydrogen atoms are present, so 30 multiplied by 1. And how many oxygen atoms are present? Only one oxygen atom is present, so you will get the answer 286 gram per mole. So this is the molar mass. What is the mass of vitamin A? The given mass is 500 milligram, and in order to convert this milligram into gram, you will divide it by 1000 and you will get the answer 0.5 gram. And then you will apply the formula molecules is equal to mass over molar mass multiplied by Avogadro number. So let's solve with the help of this formula. Molecules is equal to mass is 0.5 gram, molar mass is 286 gram multiplied by Avogadro number 6.02 into 10 raised to power 23. So you will get the answer 1.05 into 10 raised to power 21 molecules. So B part is the correct answer. How to convert milligram into gram? You know that 1000 milligram is equal to 1 gram. So 500 milligram is equal to 1 divided by 1000 multiplied by 500. So you will get the answer 0.5 grams. So students, the correct answer is B part is the correct answer. Question number 8. When 1 mole, this is mole, when 1 mole of each of the following is completely burned in oxygen, which will give the largest mass of carbon dioxide? A part is carbon monoxide, B part is diamond, C part is ethane, and D part is methane. So let's solve this question. If carbon monoxide is burned in oxygen, then we get carbon dioxide. 1 carbon on both sides. How many oxygen atoms are there now? There are 3 oxygen atoms on the reactant side and 2 on the product side. So let's balance it. So 1 divided by 2. So this 2 is in the denominator, this is in the numerator, so it will be cancelled. So this is the reaction. In this reaction we get only 1 mole of carbon dioxide. So B part is diamond, that is carbon. When you burn carbon or diamond in the presence of oxygen, then you will get carbon dioxide. This equation is already balanced. C part is ethane. C2H6 combines with oxygen to produce carbon dioxide and water. Let's balance this reaction. 2 carbon atoms are there, so 2 carbon. 6 hydrogen atoms are there, so 3 to the 6 hydrogen atoms. So how many oxygen atoms are present on the product side? 2 to the 4 plus 3, total 7. So 7 divided by 2, this 2 and this 2 will get cancelled. So oxygen atoms are balanced now. There are 7 oxygen atoms present on the reactant side. So 2 moles of carbon dioxide are produced in the C part. And the fourth one is methane. When you burn methane in oxygen, you will get carbon dioxide and water. So how many hydrogen atoms are there? 4 hydrogen atoms. Carbon is balanced. How many oxygen atoms are there? 2 plus 2, that is equal to 4. So 2 2s are 4. So in C part, greater number of moles of carbon dioxide are produced. So C part is your correct answer. C part. Students, let's solve question number 9. 1 mole of ethanol and 1 mole of ethane have equal number of molecules. 1 mole of ethanol and 1 mole of ethane contains 6.02 into 10 raised to power 23 molecules. So number of molecules is same. Yes, friends, question number 10. Methane reacts with steam to produce carbon monoxide and hydrogen. What volume of hydrogen, we have to calculate the volume of hydrogen, can be obtained from 100 centimeter cube of methane. Students, methane and hydrogen is present in the ratio of 1:3. So if 100 centimeter cube of methane is involved, then 300 centimeter cube of hydrogen is produced, because the ratio of methane to hydrogen is 1:3, and if 100 centimeter cube of methane is used, then 300 centimeter cube of hydrogen is produced. So A part is the correct answer. Yes, friends, question number 11. The Avogadro's constant is the number of atoms in 1 gram of helium? No. We know that 4 gram, this is the mass of helium. 4 gram of helium contains Avogadro number of atoms. So 1 gram of helium contains less atoms. 4 gram of helium contains 6.02 into 10 raised power 23 atoms of helium. 1 gram of helium will contain 6.02 divided by 4 multiplied by 1. So the number of atoms will be less, and that will be 1.05. So this is wrong. The Avogadro's constant is the number of atoms in 1 gram of helium? No, it is the atom in 4 gram of helium. So this answer is wrong. Then B part, molecules in 35.5 gram of chlorine. 35.5 gram of chlorine contains 6.02 into 10 raised to power 23 atoms of chlorine and not molecules of chlorine. 35.5 gram of chlorine contains 6.02 into 10 raised to power 23 atoms of chlorine. This is chlorine atom, not molecules of chlorine. The word molecule is wrong, so this is the wrong statement. C part, electrons needed to deposit 24 gram of magnesium. Yes, friends, magnesium plus 2, this magnesium ion will gain 2 moles of electron to produce 24 gram of magnesium. How many moles of electron are required? 2 moles of electron are required. Means 2 multiplied by 6.02 into 10 raised to power 23. This much electrons is required to deposit 24 gram of magnesium. So this is wrong. C part is electron needed to deposit 24 gram of magnesium. They are saying that in C part 1 mole of electron is needed to deposit 24 gram of magnesium. No, 1 mole of electron is not required to deposit 24 gram of magnesium. 2 moles of electron are required to deposit 24 gram of magnesium. So this C part is also wrong. In C part, they are telling that Avogadro number of electron is needed to deposit 24 gram of magnesium. It is not the Avogadro number, it is the Avogadro number multiplied by 2. So students, C part is also the wrong answer. D part, atoms in 24 gram of magnesium. Yes, we know that 1 mole of magnesium, that is 24 gram of magnesium, contains 6.02 into 10 raised to power 23 atoms of magnesium. So this is the correct answer. Avogadro number is the number of atoms present in 24 gram of magnesium. Yes students, so let's solve next question now. Question number 12. How many moles of oxygen are needed for the complete combustion of 2 moles of butane? Yes students, the formula of butane is C4H10. We have 2 moles of butane. So how much oxygen is required? Obviously, when butane is burnt in the presence of oxygen, carbon dioxide and water is produced. So let's balance. 4 to the 8 carbons are present. So 8 carbons. How many hydrogen are present? 2 multiplied by 10. So 20 hydrogen atoms are present. So 10 multiplied by 2. So how many oxygens are there? 8 to the 16 plus 10, 26. So 13 multiplied by 2, 26. So how many moles of oxygen are needed? 13 moles of oxygen are needed for the complete combustion of 2 moles of butane. Question number 13. If 4 moles of sulfur dioxide are oxidized to sulfur trioxide, then how many moles of oxygen molecules are required? We have 4 moles of sulfur dioxide, and how much oxygen is required to produce sulfur trioxide? So how many atoms of sulfur are present on the reactant side? 4 to the 8. So 8 atoms are present. So what is the, now how many atoms of oxygen are present on the product side? 8 3s are 24. So let's see. Sorry students, let's solve this question again. How many atoms of sulfur are there? Sorry, 4 atoms of sulfur are present, so we will write down 4 over here. How many atoms of oxygen are produced? 4 3s are 12 atoms of oxygen are there. So 4 2s are 8 and 2 2s are 4. So 8 plus 4, that is equal to 12. So how many moles of oxygen are required? 2 moles of oxygen are required to oxidize 4 moles of sulfur dioxide into sulfur trioxide. The relative atomic mass of chlorine is 35.5. What is the mass of 2 moles of chlorine gas? 1 mole of chlorine gas has a mass of 1 chlorine atom is 35.5, and mass of 2 chlorine atom is 35.5 multiplied by 2, that is 71 gram. So 2 moles of chlorine gas contains, mass of 1 mole of chlorine gas is 71. So mass of 2 moles of chlorine gas is 71 multiplied by 2, and that is equal to 142 grams. So A part is the correct answer. Which of the following statement is incorrect? 12 gram of carbon gas contains 1 mole of atom. Yes, 1 mole of carbon is 12 gram. 28 gram of nitrogen gas contains 1 mole of molecules of nitrogen. 1 mole nitrogen, that is 28 grams of nitrogen, contains 1 mole molecules, means 6.02 into 10 raised to power 23 molecules. This is also correct. Then C part, 1 decimeter cube of 1 moles per decimeter cube solution of NaCl contains 1 mole of chloride ions, means NaCl ionizes to produce sodium ion and chloride ion. 1 mole of NaCl is present in 1 decimeter cube solution of NaCl. The volume of the solution is 1 decimeter cube, and in this 1 decimeter cube solution, how many moles of NaCl is present? 1 mole of NaCl is present, and 1 mole of NaCl ionizes to produce 1 mole of chloride ion. So this is also correct. So which statement is incorrect? None of the statement is incorrect. So the correct answer is D part. Let's solve question number 16. 1 mole of propane has the same number of hydrogen atoms as 1 mole of methane. The formula of propane is C3H8. So A part is 1 mole of propane has the same number of hydrogen atoms as 1 mole of methane. No, in propane there are 8 hydrogen atoms, in methane there are 4 hydrogen atoms. So this statement is wrong. 1 mole of propane, C3H8. 1 mole of propane has the same number of carbon atoms as 1 mole of butane. Let's write the formula of butane, that is C4H10. No, in 1 mole of propane there are 3 carbon atoms, in 1 mole of butane there are 4 carbon atoms. So this answer is wrong. Then 1 mole of propane has the same mass as half a mole of hexane. So students, let's calculate the mass of hexane. First of all, let's calculate the mass of 1 mole of hexane. The formula of hexane is C6H8, and the mass of 1 mole of hexane is 86 gram per mole, and this is 1 mole. And what about the mass of, this question is mass as half a mole of hexane, means the mass of 0.5 mole of hexane will be 86 divided by 1 multiplied by 0.5, and the answer will be 43 gram. So what is the mass of half mole of hexane? That is 43 gram. So let's calculate the mass of propane. If the mass of propane is equal to the mass of half mole of hexane, then C is the correct answer. But let's see the mass of propane. When we will calculate the mass of propane, it will be 44 gram. So this is also not equal. This is also incorrect. Fourth, D part, number of molecules as in 1 mole of ethane. Yes, 1 mole of propane and 1 mole of ethane contains the same number of molecules, that is 6.02 into 10 raised to power 23. So D part is the correct answer. Yes students, question number 17. What is the mass of 1 mole of iodine molecule? Atomic mass of iodine is 127. So molar mass will be, its molar mass will be 127 multiplied by 2, and that is equal to 254 gram. So 1 mole of iodine contains 254 grams of iodine. So the correct answer is 254. Question number 18. What volume of sulfur dioxide at room temperature and pressure is produced on heating 9.7 gram of zinc sulfide if reaction takes place as follows? 2 moles of zinc sulfide combines with 3 moles of oxygen to produce 2 moles of zinc oxide and 2 moles of sulfur dioxide. So if we take 9.7 grams of zinc sulfide, then what is the volume of sulfur dioxide which is produced at room temperature and pressure? Students, let's solve this question. So mass of zinc sulfide that is given to you is 9.7 grams. Molar mass of zinc sulfide is Mass of zinc is 65 and mass of sulfur is 32, that is 97 gram per mole. So how many moles of zinc sulfide are there? Mass over molar mass, that is equal to 0.1 mole. According to balanced chemical equation, if 2 moles of zinc sulfide are used, then 2 moles of sulfur dioxide are produced. If 0.1 mole of zinc sulfide is used, then how many moles of sulfur dioxide are produced? 2 divided by 2 multiplied by 0.1. So 0.1 mole of sulfur dioxide will be produced. Then now we must know that we have this information that 1 mole of sulfur dioxide is equal to, what is the volume of 1 mole of sulfur dioxide at room temperature and pressure? That is 24 decimeter cube. This is the new information, that at room temperature and pressure 1 mole of any gas occupies a volume 24 decimeter cube. At standard temperature pressure 1 mole of any gas occupies a volume of 22.414 decimeter cube, but at room temperature and pressure any gas, for example sulfur dioxide gas, 1 mole of sulfur dioxide gas occupies a volume 24 decimeter cube. So if 0.1 moles of sulfur dioxide are present, then what is the volume that is occupied? 24 divided by 1 multiplied by 0.1. The answer will be 2.4 decimeter cube. So B part is the correct answer in this question. Your assignment is, you have to solve science tidbit on page number 18. You have to calculate the percentage yield, you have to calculate the theoretical yield, you have to solve both the questions of science tidbit exercise. Then you have to solve question number 7 of review exercise. It's just like you have to find out the limiting reactant first, and then you have to calculate the number of moles of the product. You have to practice sample problem number 1.9 and 1.10. Thank you students, and